In this video, we will discuss how to use the new zone-based firewall to block custom DNS queries in UniFi network. There will be 4 parts. First, we will talk about if in the VLAN setting you have the default DNS server, how to block custom DNS queries from your client side. The second part, what if in your VLAN DNS server setting you don't have the auto setting, how the firewall should be configured differently. In the third part, we will talk about what if your client is smart enough to use DoT, DNS over TLS, how you can block such queries. In the very last part, we will explore what if your client use DoH, DNS over HTTPS. My next video will be focusing on Pi-hole. I will talk about in details how to use the UniFi zone-based firewall to make Pi-hole works with multiple VLANs and how to use DNet to hijack custom DNS queries to point to Pi-hole. So in this video you are watching, I'm not going to talk about the details about Pi-hole. Okay, let's get started. This is my lab environment. I use a UDM Pro as the gateway. In the right side network controller, you can see I have very simple VLAN definitions, only 3 VLANs, the default network, VLAN admin, which is VLAN 10, and the VLAN IoT, which is VLAN 20. In the lower part, you can see I already opened 3 terminals for 3 clients in VLAN 10 and VLAN 20. And to help us understand how the DNS query goes, I will use 2 Wiresharks. The left side one will be monitoring the WAN part. The right side one will be monitoring the LAN part. So we will see how the 2 parts work differently when it comes to DNS queries in our different scenarios. Now let's talk about the first scenario. In UniFi network controller, if you go to your VLAN setting, for example this VLAN 20, go to the end for DHCP server management. See, by default, the DNS server is author. Author means your client, if it honors the DHCP settings, it will point its DNS server to the gateway. Then the ultimate DNS server used will be determined by the internet DNS server setting in your gateway. So if I go to internet for the primary one part, you can see for DNS server by default is author. Author means it will use whatever the ISP specifies. But for this video, just to differentiate the internet DNS server with the custom ones, let me set it to a special DNS server so that we can easily differentiate which one is the internet DNS server, which one is the custom DNS server. Okay, so here I set it to 9999. Apply changes. Then if I go to firewall, go to security, you can see now I don't have any custom firewall rules defined. And from the zone setting, you can see all my 3 VLANs, they belong to the internal zone. I'm good with that. So in this video, I'm not going to introduce new zones. I'm going to stick to the default 6 zones. Let's see what we can do to define the firewall policies. Okay, and because here we are talking about VLAN admin and the VLAN IoT, of course, before we touch the DNS, I need to first make changes to this cell, internal to internal, so that I will first block inter-VLAN traffic, which means from any source network to any destination network. Okay, block it. Yeah, now we have the block inter-VLAN rule. And for admin client, of course, I wanted to be able to access other VLANs, right? So I need to add new policy. Allow admin to IoT and default network. For source network, I would say network, select the VLAN admin. And then for action, I will say allow, and then here I will enable the auto allow return traffic. Then for destination, let me customize it to default and IoT. Save it. That's it. Add policy. See, the sequence is not correct, so I need to change it. Click reorder, then move the block inter VLAN to the end. Okay, so now I'm ready to deal with the DNS queries. So before I make any change about DNS related firewall policies, let's see what's the current situation. Let me start capturing in the 2 Wireshark sessions. You can see for the one Wireshark, I added additional filters just to filter out the queries to 1111 and 8888. They are from the gateway itself for network connectivity and the latency purpose. So I just want to filter out the noises. You can see there are already some DNS traffic going on. For example, the destination is the upper gateway for my home lab because I'm running the lab environment behind my main router, right? And you can also see some queries to 9999 already. They are from the lab gateway for other purposes, which are not related to this video. So everything you see so far, they have nothing to do with this video. Just to clear them out, let me click this button. Okay, now we have a clear start. So in the VLAN admin client, let me dig x.com. Okay, so we see the queries in both Wireshark sessions. They have different DNS servers. So let's check the LAN one. The source, of course, is my admin client IP address. The destination is the gateway. It's not 9999. Why is that? Because under DHCP server management, you can see the DNS server is author. Author means the client will be suggested to set the gateway as the DHCP server. That's why you see this result in LAN, right? And then in the one part, you can see the destination is 9999. Why? Because we set the internet DNS server to 9999. But you can see who initiated the DNS query is from the gateway. Internally, the gateway runs dnsmasq. So the dnsmasq is a proxy. It will receive the DNS queries from your local network and then send to internet. This relay from LAN to WAN is done by dnsmasq within the gateway. But that's not the focus point of this video. Let's focus on the firewall. Okay, so we just tested the VLAN admin client, right? Then from the IoT VLAN client, let me dig abc.com. Okay, see both queries are captured, so let's stop capturing. In the similar situation as the VLAN admin client. From the LAN part, you can see my VLAN 20 client reach out to the gateway. But from the WAN part, you can see it's the gateway which reach out to 9999. Okay, everything works as expected at this moment. Now for this second VLAN IoT client, let me make it a troublemaker. So it doesn't want to follow the DHCP server's setting about DNS server. It wants to use its own custom DNS server. Let me go to the network setting for wired, go to settings, then go to IPv4 for DNS. Let me disable automatic, then hard code it to, let's say, 4444. Okay, apply changes. Then to make the setting effective, I need to go to the setting and disable wired, enable it again. Now it should be effective. This time, let me dig x.com. Okay, packets captured, stop capturing. Let's check the LAN first. See what's the difference? This time the client directly reach out to 4444, completely bypass the gateway. And the same thing happened in the WAN part. You can see the same query to 4444. Of course, because of net, now you can see the source is the gateway instead of the local client, right? But it's the same DNS query, directly initiated from the client. So this is a situation we want to avoid. We do not want the client to bypass the gateway. We want to block this type of DNS queries. How can we achieve that? We need to create a new firewall policy, because what we want to block is from IoT device to internet if traffic is DNS query. Right? So we need to deal with this particular cell in UniFi zone-based firewall, which is from internal to external. So let me click on it, create a new policy, block IoT custom DNS. For source zone, I only want to limit the queries from IoT VLAN because I don't trust it. Then for source part, I don't care. For action, it's block. For destination, I'm okay with any destination DNS queries. I want to limit the part to DNS, which is 53. And then for protocol, I want to limit to TCP UDP. That's it. This is the simple block rule. to block IoT's custom DNS queries. Add policy. Then we are done. Someone may ask, are you sure if you brutally block all the DNS queries from IoT, how it can use the supposedly allowed DNS server, which is 9999? Will it be blocked as well? Hold your thought, you will see. From the two Wiresharks, let me start capturing. So now for the two IoT clients, the first one follows the DHCP's setting. It will use the gateway as the DNS server, right? But for the second client, it violated the DHCP server setting. It used its own DNS server. So the second client is what we want to block. So let's see whether it's the case. From the first IoT client, let me dig x.com. Okay, apparently the query result was already cached in the gateway. That's why from the one Wireshark, you don't see the query, right? So let me use a brand new domain name. Let's say disney.com. So now from both Wiresharks, we see the expected DNS queries. From the LAN, you can see it's the client reaching out to the gateway. But from the one, you can see it's the gateway reach out to 9999. It's completely expected. We are good with this result. Then let's see what will happen for the second client. So let me dig hbo.com. See, the query hangs there. It will fail. See the query timeout. Then from the Wireshark, you can see in the LAN part, yes, the client sent out 3 queries to 4444. But in the one part, you can see the query was never sent out to the internet. That's why from the LAN part, the query never received the result. That's why our client failed. We have completed the setting for this scenario successfully. Now let's explain why for the first IoT client, the DNS query to 9999 still works. You need to understand how the traffic goes for the first IoT client. So when it sends out the DNS query, it will not directly send it to the internet. That's what we want to block, right? Instead, it will send the query to the gateway. What firewall rules is related to this query is from internal to gateway, right? So you can see for the existing policies, there's nothing to prevent that. That's why that DNS query was successful to be sent out to gateway, right? And then when the gateway send out the query to 9999, it will follow this cell from gateway to external. You can see by default it's allow all. So that's why in the zone-based firewall, this DNS query to 9999 is not contained by your firewall rules from internal to external. That's why our brutal firewall rules will not impact the valid queries to 9999. I hope it's clear. In the new zone-based firewall, you need to clearly understand for a given traffic which cell you want to do the firewall rules. If you do it in the wrong cell, you will not get the correct result. We are done with this scenario. Let's move on to the second part. In the second scenario, what if you do not want your clients to use your gateway as the DNS server? Instead, you want to specify a specific DNS server. If that's the case, how you want to change your firewall to enable that? Let's use IoT VLAN as an example. So if I go to the network setting for VLAN 20, for DHCP service management, you can see now for DNS server is altered, right? So let me change it. Specify 9999 as the recommended DNS server. Apply changes. So let's say at this moment, we inherit the firewall setting from previous scenario, right? So let's see whether it works for this type of DNS setting. For these two IoT clients, before doing any testing, I need to refresh the DHCP settings. The reason is we changed the VLAN setting in UniFi gateway side. So we need to make those changes effective. So in both IoT clients, let me go to wired network, disable it, enable it. Okay, done. Let me start the Wireshark capturing for both WAN and LAN. Then from the left side IoT client, let me dig signer.com. Okay, you can see from Wireshark for LAN, yes, it did try to reach out to 9999. Why 9999? Because in the VLAN setting for VLAN 20, we say, okay, for DNS, we recommend to use 9999, right? That's why for the left side client, it directly reach out to 9999. But in the one part, you can see we do not have such traffic to 9999. By the way, these two have nothing to do with the testing we did, okay? Because the current firewall, this left side client is not allowed to directly reach out to 9999. That's why this fails. For the right side, remember it still has the overwritten DNS setting. It wants to reach out to 4444, right? So let's do the same dig using the right side client, dig signer.com. Okay, see, similar situation. So from LAN, we see the 3 tries to 4444, but in one part, nothing's captured because of the same reason due to our firewall rules, right? Okay, we are good so far. For the right side client, the result is what we want. We still want to prevent it, right? But for the left side one, we do want to enable this type of access because in our VLAN setting, we want it to directly reach out to 9999, right? So then the way to enable it is in network controller, we go to security. We don't change our existing firewall rules from internal to external. We still have this firewall policy. We don't want to change it, but we want to create a new one, which is to allow IoT VLAN to use 9999 as DNS. For source network, I want to choose IoT. For destination, I want to say IP and then specify 9999. That's what we want to do. For part, I want to specify DNS, and the protocol, I want to say TCP or UDP. That's it. I need to add this 9999. Okay, done. Add policy. Okay, it's added, but you can see the order is wrong, right? We need to reorder it. Drag this allow 9999 to the beginning. Done. Then let's validate the return traffic, which is from external to internal. By default, it already allows return traffic, so we don't need to change anything. We should be good. So now we are done with the firewall setting. The only change we made was to add a new policy to allow IoT to access 9999's DNS. Okay, let's validate whether it works. Let me start capturing. Then from the left side, IoT client 1, do the same digging, dig signer.com. Okay, see the packets were captured in both LAN and WAN. From LAN, the client directly reached out to 9999. It got result back. Good. From WAN, the gateway reached out to 9999. Okay, as expected. So it works for the left side client 1. Our new firewall policy shouldn't impact client 2, which means the client 2 currently it is still using the overwritten 4444 as the custom DNS. We still want to prevent that. Let's see whether it's still the case. Let me dig signer.com as well. See, the DNS query fails. It sent 3 tries to 4444, but none of them reach out to 1. All of them failed. That's great. That's expected. So this scenario is very simple. Just based on our previous scenarios setting, we simply added one new allow firewall policy. We are good in this scenario already. Then let's move on. In this scenario, let's talk about DoT, DNS over TLS. Starting from this scenario, things become complicated because your client is smart enough, they will not use the traditional DNS. Instead, they try to use encrypted protocols, for example, DoT. So in this lab environment, in the leftmost virtual machine, I already installed Pi-hole and Unbound. I won't cover the details about the setup. If you are interested, please watch my another video. I will put the link in the description. For this particular Pi-hole plus Unbound setup, if I check the Unbound configuration, let me show you the Pi-hole.config. You can see it will listen to this IP address, this part. Then at the end, you can see the TLS upstream is enabled. It will forward the query to 8888. The port number is 853. This is a DoT, DNS over TLS setup. So we can simply set up such environment by using Pi-hole plus Unbound. So this is the Unbound configuration, right? If you go to Pi-hole, go to setting, DNS, you can see instead of pointing Pi-hole to a upstream DNS server, I set a custom DNS server, and which is the local IP address and the port number, which are both specified in the Unbound configuration I just showed you. So this is how Pi-hole is connected with Unbound. Then from this Pi-hole virtual machine, by the way, it's also within VLAN 20, I can go to the network setup. For IPv4, for DNS, I can simply say 127.0.0.1. That's the local IP address which point to Pi-hole. Keep in mind, if I set the DNS this way, this DNS query will not go through the firewall at all because it's completely local, right? It will completely bypass the firewall. Okay, apply changes, then disable wired network, enable it again. Now it's effective. Then for the IoT client 1 and IoT client 2, remember we changed the VLAN 20 setup in previous scenario, right? So for this scenario, let me change it back. In network controller for VLAN 20, let me go to the DHCP service management. For DNS, let me change it back to author, which means it will point to the gateway automatically. Then from the IoT client 1, let me quickly refresh the DHCP setting, and for client 2, let me go to the wired setting, and for IPv4, for DNS, remember this 4444 was our previous setup for scenario 2, right? So for this scenario 3, let me change it to the left side Pi-hole server's IP address, which is this one, .20.119. Okay, apply changes, then disable the network, enable it again. Now everything should be effective. For the two Wiresharks, let me start capturing. Then let me start from the Pi-hole server. So from the Pi-hole server, let me try something like dig canada.ca. Okay, see the strange thing for LAN and one Wireshark, see the current filter is DNS, right? None of them captured any related DNS queries from this Pi-hole server. Remember I said for this Pi-hole server, I set its DNS to local IP address, which means that particular DNS query, yes, it will be using DNS protocol, but it will not go through firewall, go through the router. That's why the Wireshark for LAN cannot capture it, right? So once the query reach out to Pi-hole, Pi-hole will reach out to Unbound, and Unbound will use DoT, the DNS over TLS, to directly reach out to Google, which means that effective DNS query is not in DNS protocol. So to really see that particular traffic from the one part, we need to change the filter to TLS. Okay, you see the TLS traffic from the gateway to 8888, and everything is encrypted. I cannot tell what's happening, but these traffics are related to these DNS queries I did in the Pi-hole and Unbound server. Okay, so this is what happened in the Pi-hole server itself. Then let's test the same thing in the IoT client 1 and client 2. Let me restart capturing. Then from the IoT client 1, let me dig cbc.ca. Okay, this time in the LAN part for Wireshark, yes, we captured that query, right? Because this client 1 still use the gateway as DNS server and will still use the DNS protocol. That's why from LAN part, we are able to capture it. And even from the WAN part, if we go back to DNS as filter, you can see the query to 9999 to query the cbc.ca, right? So for this particular client 1, everything still works in the same old way. But what about the client 2? Remember, we point its custom DNS server to the Pi-hole server, right? Let's see whether we are able to capture anything for this client 2. So let me dig ctv.ca. See, we have the same situation as the Pi-hole server. First, from the LAN part for Wireshark, we don't see anything captured about DNS. And then from the one part, the same thing, nothing about DNS. But if we change the filter to TLS, see, we can see a whole bunch of queries starting from this one. It is about our ctv.ca query. Okay, now for this scenario, what we want to resolve is we want to block the similar DNS access from this Pi-hole server and from this client too, so that they cannot use the DoT to query custom DNS servers. Let's see how we can do that using zone-based firewall. To block DoT in firewall is very simple because it works in the exact same way as blocking traditional DNS. For DNS, we block port 53, right? Then for DoT, we simply need to find out what's the port. So in the one port Wireshark, let me pick this particular packet. If I go to the TCP section, see it has destination port 853. This is the port for DoT. Then in network controller, let me go to security for zone-based firewall. By the way, from internal to external, I have already removed the previous blocking DNS policies, so we are starting from scratch. Let me create a new policy, block DoT, and for source zone, in the same way, let me select VLAN IoT. For action, I want to block. For destination zone, I do not want to specify IP. I simply want to limit the port. So this time, let me say custom. Then I say 853, which is what I got from Wireshark. Then for protocol, let me say TCP because we are talking about TLS. Yeah, that's it. Let me add a policy. Okay. We should be good. Then let me quickly validate it, restart Wireshark capturing. Then from the Pi-hole server itself, do the same digging, dig canada.ca. Yeah, apparently this time it's successful because it's already in cache of Pi-hole. So let me try a brand new domain name. Let me say dig db.de. Okay, see it hangs there, right? From Wireshark, for both WAN and LAN, I don't see any related packets, and you can see the DNS query failed. Okay, let me try from the second IoT client, do the same thing, dig db.de. Yeah, the same result, it failed. And of course, from the first IoT client, there should be no impact. Let me validate it, dig db.de. Yeah, it's successful. Okay, for DoT, it's very easy to block. It's just we need to use different part, right? Then let me quickly move on to the last part, DoH, which is the troublesome topic. Because DNS and DoT can be either easily blocked or easily hijacked, people are using DoH more frequently. If you compare DoH and the previous DoT from firewall perspective, the real difference is on the port. For DoH, because it's using HTTPS, of course the port is 443, right? But just because of this seemingly minor difference, it caused DoH almost impossible to block. You will see why. dnscrypt-proxy is free and widely used to support encrypted DNS. You may know even for UniFi gateway, if you go to security under protection, you can see this encrypted DNS. Previously, it has a fancier name. It's called DNS Shield. Internally, it is using the same dnscrypt-proxy to provide encrypted DNS support based on HTTPS. Of course, if you enabled this gateway's encrypted DNS, you do not want to block it, right? But for this video, what we are discussing is what if your client simply install the dnscrypt-proxy locally. Then the client wants to use the local dnscrypt-proxy to get DNS service. How you can prevent that? So in this lower part DNSCrypt virtual machine, I already installed and configured dnscrypt-proxy. Let me show you the configuration file. Go to etc dnscrypt-proxy. Then let me show you the configuration file. it has a URL for sources. If you visit this URL, you can see this openly available DoH server list. For this video, I simply pick a random one, this one, as an example. This is a add filter -ADL server. So go back to the configuration. See here, the first line, I say the dnscrypt-proxy will listen on this local IP address and this regular DNS part number. Then it will use the server I just mentioned, a random DoH server. That's it. That's the extremely simple configuration you need to enable DoH locally. Then we can see it in action. From this local machine's network setting, if I go to IPv4 for DNS, let me disable the automatic DNS and then use the local IP address we just saw in the dnscrypt-proxy configuration. Apply changes, disable network, enable again. Okay, now the setting is effective. Then go back to the terminal. Let me start capturing in the Wireshark. You can see for the one part I filtered to TLS again, because this time we are talking about DoH is over HTTPS, and HTTPS is also based on TLS. Okay, so now let me start my very first DoH DNS query. Let me dig, let's say UI.com. Okay, so you see a lot of packets are captured. Stop capturing. Then from the LAN part, you can see nothing's captured because this is DoH. It doesn't use the traditional DNS. Then from the WAN part, let's see what happened. So this gateway will reach out to this server. This server is the AD filter -ADL I specified in dnscrypt-proxy. Right? And then a whole bunch of back and forth. They are all based on TLS. They are encrypted. So seemingly it's almost the same as previous DoT. But if you go to the packet detail for part, see, destination part is alarmingly simple. It's 443. 443 is the part used by HTTPS, and nowadays almost all of the websites you visit use HTTPS, use 443, which means you cannot simply block the traffic for this part, because in that way you will block almost all of your internet access. So then the only thing you can do is to blacklist the DoH servers. Let me show you what I mean by blacklist. From the UniFi network controller, go to security, firewall. If I go to this cell from internal to external, let me delete the block DoT, then create a new proxy. Let me say block DoH. For source network, the same thing, IoT. Then for action is block. For destination, let me specify the part, which is HTTPS part 443. Okay, so then this time I do need to specify the IP because I don't want to block all the websites, right? This time let me use the IP address I got from Wireshark, this particular one. Okay, add the IP address. So this is the blacklist I was talking about. So you need to specify the DoH server one by one. You already see the problem, right? Because nowadays new DoH servers appear on the internet every single day. It's mission impossible for you to exhaust all the available DoH, and even if you try very hard, it will be a very heavy maintenance work down the road. So in this video, let me simply blacklist this one single DoH server. Then for protocol, of course, TCP. Yeah, that's it. Add policy. Now let me restart capturing from the dnscrypt-proxy machine. Let me dig another domain name. Let's say store.ui.com. See? It hangs there and nothing's captured in both Wiresharks. The reason is we blocked the connection for the destination IP address, which means the TCP IP connection cannot be established, which means you won't capture anything from Wireshark. Okay, we successfully blocked this particular DoH server, but as I mentioned, it's far from enough. There are tons of them available now, free on the internet. In fact, that's the point of DoH. it makes your firewall blacklist blocking almost mission impossible. In fact, there is an easy way to blacklist the DoH servers, which is using the old traffic rule. Now Ubiquiti integrated to the zone-based firewall. Let me show you. Let me first pause this custom block DoH policy, then create a new one. Let me say block DoH using traffic rule. And for source zone, the same, DoH only. Action block. This time for destination zone, instead of specifying IP, I select app. Then I specifically search for DoH. See, there's a application, it's called DoH. So technically, internally, the system simply using its own source, compile a set of DoH servers so that you can block them all together. That's the point of using app. So basically, you are not relying on yourself, you are relying on the system to do that for you. Of course, the benefit is it will save you effort. The negative part is you are giving control to Ubiquiti. Who knows how and where and how frequently Ubiquiti will get the DoH server updated, right? So it's up to you about whether you want to use this way. Let me proceed. Protocol still TCP. Okay, add policy. Now it's effective, right? Let's validate it. Let me start capturing. So from the dnscrypt-proxy, remember I still have the existing setting, which is using the ad blocker DoH server, right? Let me dig store.ui.com again. See, the DoH query was successful. To put another way, our blocking failed. So that's what I said, because by using this way, on the surface, it seems it should work, right? But under the hood, you are completely relying on the quality of how Ubiquiti implemented. Apparently, it doesn't work well for now, okay? So still, you may want to go back to the original blacklist method I talked about. Of course, I'm not saying there's no way to block DoH. For example, you can utilize SSL inspection, but that's out of scope for this video. Okay, this is the end of the video. Thanks for watching.